Hello, welcome and karibu to our Sharing Best Practice event for Tanzania. My name is Ewan Patterson and I am the Media Manager, Communications Manager for the GlobalSeaweedSTAR programme. I'd like to say good morning, good afternoon or good evening to you wherever you are in the world, and thank you for attending today. Today is a very special event for our programme, but particularly for our partners in Tanzania. They will be able to showcase what they have been working towards as part of the programme and share with you a very special launch today. For some general housekeeping today, please leave your microphones off if you do have the ability to use that while the presentations are ongoing. If you're a guest, you can use the Q&A function, which you can see displayed at the top of your Teams screen. We do welcome questions during the event. They will be logged and will be asked at the end of today's session, during which time we'll have a question and answer session directly for those who have spoken today. Shortly you'll be hearing from our programme leader in Tanzania, Dr. Flower Msuya. But I'd just like to mention that in terms of GDPR compliance, we will be recording today's meeting, so if you do not wish your name to be included in the question and answer section at the side of your screen there, please join the meeting anonymously. That way your name will not appear. The recording will be shown on our website and social media after the event. So again, just in terms of GDPR compliance, if you wish to remain private, please join the meeting anonymously. I'd like to now hand over to Dr. Msuya, who will give you the welcome from Tanzania. Thank you.
Good morning, good afternoon, good evening to you all in your respective locations. Thank you very much for registering and joining us today. This is going to be a 2 days webinar, as you have heard. And this webinar is based on the project GlobalSeaweedSTAR that has been going on at the Department of Botany, University of Dar es Salaam in Tanzania. The project actually started at the end of 2017. Our journey started 4 years ago, 2017, with 4 early career researchers getting training in UK for 6 months. That was in January 2018. On their return, we have been conducting research together since then. And in our project, we have 4 work packages or 4 research areas that we call work packages. We have an area on genetics and taxonomy, looking at different aspects of genetics and taxonomy of our seaweed. We have a research area on biosecurity, to look at biosecurity in the seaweed farms and in other areas where seaweed is being used. We have a research area on diseases. We have been looking at different aspects of seaweed diseases, and a 4th area on resilience of farmers, to look at how resilient the farmers are and what can be done to improve their resilience. Tanzania is one of the 3 countries that are working together with in this project. We have also Philippines and Malaysia that we are collaborating. For our project, I wish to thank our overall project leader, Professor Elizabeth Kotia Cook, from the Scottish Association of Marine Sciences. Thank you, Liz. You have been very instrumental in running this project and coordinating everything from UK to make sure that Tanzania and other developing country partners are doing their work well. I also wish to thank you, the work package leaders, leaders of the different research areas. We have Professors Juliet Brody, Claire Gachon, and Louise Shackson. We have been working together and collaborating very well, and I thank them very much. It has been a very fruitful, actually, 4 years journey. So we have conducted research, and now we have results of this project. And we are going to share these results with you today. Results of each work package, each research area, and all this would have been possible without funding from the UK Research and Innovation. They are the ones who funded this project, and we really thank them for this. We also extend our thanks to the Scottish Association for Marine Science, who have been the coordinating institution for this project. I wish also to thank the Tanzanian GlobalSeaweedSTAR team at the University of Dar es Salaam for working together so well. Just to mention that our project continues until the end of December this year, then we will have finished our 4 years. With these few remarks, I just wish to welcome you all to our webinar. We are happy to have you and enjoy the 2 days together with us, and thank you very much.
Thank you there to Dr. Msuya, who has done a fantastic job for us in Tanzania, leading our research there. Having Tanzania on the project has made our program purely global, and funded by the Global Challenges Research Fund. It's important that we had that spread across the globe in the seaweed industry. We're now going to hear from Dr. Esra Mvungi, who is from the University of Dar es Salaam as the head of the department of the botany department at the university.
Good morning, dear participants. GlobalSeaweedSTAR project leader, Professor Elizabeth Kotia Cook, work package leaders, developing partner leaders, early career researchers, postdoctoral researchers, invited participants, ladies and gentlemen. On behalf of the University of Dar es Salaam, I would like to welcome you all to our 2 days online workshop on sharing best practices in seaweed industry under the GlobalSeaweedSTAR project in Tanzania. The University of Dar es Salaam has been the focal point of this 4 years project since 2017. I wish to thank Dr. Flower Msuya, the developing partner leader of GSS in Tanzania, and without forgetting Dr. Amelia Borio, the co-developing partner leader, for their tireless effort in coordinating all the project activities. I also wish to thank early career researchers and all individuals who in one way or another contributed to the successful completion of this project. The team members of the GlobalSeaweedSTAR project in Tanzania have been working diligently on various activities of the project, and today they are ready and happy to share detailed findings of the 4 years of research, and I feel honored to open this noble event. It would have been good to have all of you come to Tanzania and join us physically, but due to COVID-19 pandemic, this has been impossible. However, we still have a lot of opportunities to work together in future. Thus, I welcome you to the University of Dar es Salaam for future collaboration in similar and other research works, or in student exchange programs and the like. With these few remarks, I declare this online workshop on sharing best practices for the GlobalSeaweedSTAR project in Tanzania officially open, and I wish you all a fruitful seminar and enjoyment for all other activities of this workshop. Thank you all for your attention and for joining us.
My thanks there to Dr. Mvungi for that welcome. We now move on to a very exciting part of today's meeting. Our partners in Tanzania will be launching their seaweed disease manual. This is something they've been working towards throughout the programme. We're now going to hear from Dr. Nsuya and Miss Ivy Matoju, who will give remarks and a presentation. And that's before Dr. Nsuya officially launches the seaweed diseases manual. So I'll hand over to Dr. Nsuya.
Hello, can you hear me? Yes, hello. Sorry, the button was not working well, this unmute button. So thank you again all for joining us today. As you have heard from Yuan, we are going to launch our seaweed diseases manual, diseases that are found in our seaweed farms in Tanzania. So we are going to display just the first cover and talk about the manual. But this process of preparing the manual was a long one. We prepared it as a Tanzanian team, gathering all the information we found in our research and our different expertise, and we shared this the draft of the manual with the stakeholders, very special stakeholders, who read the manual and gave us their input, their comments about this manual. And I wish to thank all of these anonymous stakeholders, or these stakeholders that we chose. Actually, we chose 5 main stakeholders who reviewed this manual. The manual is in 2 languages, in Kiswahili and in English. So our stakeholders also reviewed the manual for both languages. From the comments that we got from them, the very useful one actually, we shaped our manual to make it read better and look better, and this is what we are going to see because of the good comments that we got from the stakeholders. And because of the comments from the stakeholders, most of them thought that the language we used may not be very as simple as we think to some of the farmers. So they suggested that we make a smaller booklet for the farmers that has simple language and photos, just so farmers can see and act according to what they see on the picture and on the few words. This one was really a good comment, and we have also prepared this booklet for the farmers, and we will work on it and finalize it later. For this launch, we had thought of actually having hard copies, on around the hard copy of the manual. Then we will have a celebration of cutting the ribbon and so on, but it has not been possible. It took a long time. So we are launching today the electronic version of the manual. I wish to thank the Scottish Association of Marine Science. Maeve Eastern Hubbard and her team have been working very well and very successfully in doing the layout of the manual, and I really wish to thank them for this. And this manual is going to be online very soon. When we finish this webinar, we will finalize the layout, and the manual will be online. So to you participants, have your preference. For example, if you want to have the e-version, the soft copy version of the manual, and you want to access it online, you can access it online. If you have special requests, you can send us email so that we send you the manual. And some of you may have interest in receiving hard copies. So if you are interested in receiving a hard copy or hard copies for maybe yourself or for your library, you can also email us and give us your full address, and then we will send you the manual. Now, I would like to say that we are going to have a presentation of the manual, page by page, talking about what the manual is about, what we have been addressing. This one will be a presentation by our colleague, our early career researcher, Ivy Matoji, who has been working very hard in the writing and the presentation of this seaweed diseases manual. So without further ado, I would like to welcome Ivy to make her presentation. Then after that, we will follow with the actual launching of the manual. So thank you very much, and welcome Ivy for your presentation.
Good morning. I am Ivy, and I'm presenting a brief look into the Seaweeds, Diseases and Pest manual that we have developed as part of the project. Thank you. After 6 months of skills training and knowledge sharing in the UK that resulted with protocols developed for data collection, the in-country team prepared to begin the project activities. As part of our initial activities in-country, we wanted to test out the protocols and related activities, and we conducted a trial run in Bagamoyo with regards to seaweed sample collection. During the trial run, we realized that it would be easier if there was a form of a picture guide that would help us and the local guides quickly identify the seaweed and visually say it is healthy or diseased and aid in the collection. As the guide developed, it became clear that it had the potential of aiding farmers and future researchers who are interested in the field, and evolved into the manual we have today titled Diseases and Pests of Cultivated Seaweeds, Ficus and Ucuma in Tanzania, and in Swahili, Magonjwa na Visumbufu vya Mwani unaolimwa Tanzania. As we developed the manual, we kept 3 things in mind. We wanted the manual to be accessible, informative, and helpful to the stakeholders of the seaweed value chain. With this in mind, we looked at the language to be used, determining that having a bilingual manual of Swahili and English, which are the 2 main communicating languages in the country, would ensure that all stakeholders would be able to understand and utilize it. We also took into account that we did not only want to state the problem, but also provide coping mechanisms that can be employed to deal with the issue, and to ensure that the information being provided was well-rounded and not just only text. We sought to use images and illustrations to transmit the message. Apart from developing the manual internally, we sought comments from the entire GlobalSeaweedSTAR team, and also conducted a review process with the targeted stakeholders, who included researchers, policymakers, and farmer representatives, to determine the suitability and usability of the manual. One of the key outcomes of these sessions was the recommendation for an accompanying booklet to be developed that uses less scientific language to ensure that the information shared in the manual is accessible to all stakeholders. This accompanying booklet will be covered briefly in the talk as well. Now, I would like to briefly take you through the contents of the manual. The manual starts off with a brief introduction to the history of seaweed cultivation in the country, species of seaweed that can be found within the country, and the characteristics of healthy cultivated seaweed. It is then followed by the main topic of the manual, where there is a more detailed look at the diseases and pests that affect cultivated seaweed. It outlines the known symptoms of the diseases, describes the pests and their effect on the crops. Each section is accompanied with images to illustrate the point. It ends with a section on additional hindrances that affect seaweed cultivation, such as silt settlement. The next section is the helpful section, whereby it provides practical steps that can be employed by farmers to reduce the occurrence and impact of aforementioned diseases and pests, and accompanied with an instructive illustration. Also covered are steps that an interested party can take if they want the affected seaweed to be scientifically investigated, and ends with an appendix that is designed for researchers, outlining a few protocols developed within the GlobalSeaweedSTAR project for said scientific investigation, such as histopathology through microscopy. I would also like to mention the accompanying booklet briefly. During the review process, it arose that some of the Swahili words were too new to be easily understood and might exclude the stakeholders that the manual is looking to help. In response, it was determined that a small leaflet or booklet that used more readily understood phrases and briefly outlined the key messages of the manual should be developed. It is entirely in Swahili, entitled Kichitabu cha magonjwa na visumbufu vinayoathiri mwani unaolimwa nchini Tanzania na jinsi ya kupambana navyo. It briefly outlines the diseases and pests, the symptoms and measures that can be taken to reduce the occurrence. The hard copy version of the manual will be readily available at Milimani Campus Botany Department and at the National Library for the mainland, and at the Zanzibar Seaweed Cluster offices in Unguja for the islands. Soft copies or digital versions are available on the GlobalSeaweedSTAR website. We would like to say a big thank you very much to all who participated in making this manual, and thank you all for your attention.
We now move on to. Sorry, Flower. I was just going to reintroduce you there to actually launch the diseases manual. So I'll let you carry on. Thank you.
So members, after have heard from Ivy, thank you, Ivy, for taking us through the journey of the manual and the small for the simple language to be used by the farmers. Now it is the event for launching the half of the team of the GSS at the at the University of Dar es Salaam. So the manual on diseases and pests of cultivated seaweeds, Capaphycus and Eucuma in Tanzania is now officially launched. Yes! Yes!
Yes. Yes.
Yes.
Thank you very much, and I share in your excitement at the launch of the disease manual. A lot of work has gone into that, so well done everybody in Tanzania for your work towards that. As I said before, it's a truly global project because of your involvement, and that's a fantastic effort from everybody involved. Thank you. I think we shall move on to the next part of the programme, where we will be hearing from Professor Elizabeth Cottier-Cook, who is our programme leader. Professor Cottier-Cook has led the programme and overseen developments in all of the countries involved, so it's been a huge task. And her vision has come to fruition as we approach the end of the project, so we will hear a little more from her just on that. Thank you.
Hello everyone, my name's Professor Elizabeth Cottier-Cook and I'm the lead researcher, principal investigator for the GlobalSeaweedSTAR programme. I'm absolutely delighted and honoured today to have been asked to speak to you all today at this sharing best practices for the Tanzanian seaweed industry. Thank you to all at the University of Dar Salaam for organising this along with colleagues at the Scottish Association for Marine Science. So, why on earth have we spent the last 4 years talking about seaweed or researching seaweed? Well, as I'm sure many of you are aware, it's now $14.7 billion activity each year. Aquaculture production has grown exponentially over the last 50 years compared to wild harvesting that really barely has changed. Huge demand from all over the world for products that we use every day of our lives, toothpaste for example, but also treats such as ice cream, soya milk and a whole variety of other commodities all include seaweed or its derivatives. A lot of the seaweed production also takes place in low to middle income countries, and of course Tanzania is one of the major producers globally of the red seaweeds Capophycus and Eucuma. So there are challenges though, there are definitely challenges to growing this seaweed and many of them are biosecurity related. So there are pests and disease outbreaks that can lead to significant losses in production in Tanzania alone, but this is happening all over the world now. And these losses can lead to catastrophic socioeconomic impacts on communities that are really reliant on seaweed production. So back in 2016, on a previous programme, myself together with various colleagues around the world, wrote a policy brief that was published by the United Nations University and the Scottish Association for Marine Science. And in that policy brief, we came up with 8 key policy recommendations. A number of those, as you can see, are highlighted. One of them is about setting up centres of research excellence, other about setting up national seed banks, looking into maintaining genetic diversity in wild stocks, looking at exercising the precautionary principle when introducing new or non-Indigenous cultivars. And the 5th one that we've been really focusing on in this particular project is looking at developing and enhancing biosecurity programs. So these are the things that we'll be concentrating on today. So for the GlobalSeaweedSTAR programme then, our vision was to use specialist UK science capacity to grow research and innovation capability for developing countries engaged in seaweed farming. We had 4 key sort of areas of research that we were going to be looking at. The first one was to be looking to produce new innovative tools and diagnostic techniques to help detect those pests and diseases when they were in their early stages of development before the big outbreaks occurred. We also have been looking at trying to come up with new management procedures and pathways to help the farmers stop the pests and pathogens, pests and diseases from actually arriving in the first place. And if they did arrive, then helping them with techniques and practices of how to stop them from spreading. We've also had a component of the team looking at trying to breed and come up with new, improved cultivars that were more resistant potentially to diseases and pests, and also more resilient to the impacts of climate change. And fourth, but totally, absolutely not least, it was about working with the seaweed farmers, looking at ways in which we could empower them within the industry, particularly the women that form a large majority of the workforce, looking at trying to empower the seaweed farmers to get a better price for their crops and better working conditions. So thanks to UKRI's or UK Research and Innovation's Global Challenges Research Fund, we were awarded £6.2 million for a period of 4 years between 2017 and 2021. So our project comes to an end this December. We, in the UK, there were 4 key partners, ourselves at SAMS, the Overseas Development Institute, the Natural History Museum, and CFAS, which is a government research agency in England. And our key primary partners for this project were Tanzania, the Philippines, and Malaysia. We have, though, worked with an additional 15 seaweed producing countries sort of worldwide. So this truly is, or truly has been, a global program. 85 scientists and more counting involved in this program. It really has been an incredible achievement. So as part of the funding that we received as well, a component of that was put aside to help fund additional projects through the GlobalSeaweedSTAR Fund. And I'm pleased to announce that we funded over £840,000 worth of additional work to what the core team was going to be able to produce. So we funded 15 research projects up to £50,000 each. 26 travel grants. That was, of course, pre-COVID, when we were able to actually travel to various conferences and special international ecological events, which was wonderful. Obviously, after COVID, we changed the travel fund into a capacity building fund. So we were then able to award another 23 grants to people to actually go to attend virtual online conferences, but also to set up their own conferences and workshops, which has been wonderful to see. So all in all, with all of this, it's been incredible that we have established a unique global partnership, or a unique global network of specialist seaweed researchers spread all over the world. It's been incredible. Other achievements, other impacts that we have had from this program. So one of the key things was about building capacity and training the next generation of seaweed researchers. And as part of the program, each of our core partners took on 4 early career researchers that have been fully paid throughout and trained throughout this program. So it's absolutely wonderful that many of them have now gone on to secure full faculty positions at the universities which we're partnered with. Obviously, another aim of ours was to build sort of institutional capacity, organisational capacity, and one of these is through infrastructure. So we've been delighted that we have been able to contribute to new laboratories, to new herbariums, digitisation of resources. So that has been wonderful to be able to be part of. And finally, we have been able to work and collaborate with organisations from local, national, or regional and international scales, and one of them being the United Nations Food and Agricultural Organization, FAO. And it's been great to see how open they have been to further discussing the inclusion of seaweeds and aquatic plants into their thinking, because of course prior up to just a few years ago, this was very much dominated by finfish and shrimp and crustaceans. So to bring seaweed into that aquaculture envelope at the FAO has been excellent to see. The other impacts we've been running training workshops. We've had them running and introducing, within each of our partner countries, but also bringing international guest scholars along to some of those workshops as well. We've spoken to over 600 seaweed farmers, surveyed them, discussed ideas with them, and they've fed obviously their ideas into our ongoing research. And we've also delighted to say that we have now trained over 30 international master's students as part of the International Erasmus Mundus Joint Master Degree on Aquaculture, Environment and Society. We created and validated a module, a 30 European credit transfer system module, as I say, that has now trained 30 master's students and will continue to progress along into the future. So it's very much a key outcome from this is that we are beginning to sort of really build capacity at international, national and local scales, which can help develop and promote and increase economic activity in this particular aquaculture sector. So in terms of looking at sort of legacies, what is it that we're leaving behind when we finish this programme? Well, later on this year, we will be publishing both an international and 3 national policy briefs, one for Tanzania, one for Malaysia and one for the Philippines. So these international policy briefs together will provide key recommendations for industry and governments and various stakeholders addressing each of the United Nations Sustainable Development Goals. We have also produced over 125 publications so far in this project, including 25 open access internationally peer-reviewed research papers, which is an incredible feat. And we probably have the same again to go by the time we've completed writing up and analysing all our data. We've also produced an online digital atlas of seaweed diseases, a global biosecurity policy database, which both can be found on our website, a number of YouTube training videos and animations, posters, training manuals, standard operating procedures, the list goes on. But most importantly, and what I'd love to share with you now, is that we are about to publish later, just in a couple of months, hopefully, a progressive management pathway for aquaculture biosecurity, specifically for seaweed. This is in collaboration with the FAO, and hopefully I look forward to discussions with members of, yourselves, members of the audience here, but also national governments of how this PMP for seaweed can be rolled out within your country. And I would also like to say that we have now, we're about to officially launch a sort of seaweed academy, a seaweed training academy here at SAMS, which I hope, very much hope, will continue way into the future and offer accredited training for seaweed farmers and extension officers and government officials within the seaweed industry. So just to finalise, I can't thank enough the team, the Tanzanian team, particularly Dr. Flower Masua, who has so wonderfully led her team of early career researchers over the last 4 years. I'd also like to thank Dr. Amelia Bureau from the botany department, again, who has helped Flower in steering the ship and making this such an incredible program in Tanzania and across the world. So thank you to everyone involved from the Tanzanian team, and I'd just like to thank you all and to leave you all with a save the date. We have a GlobalSeaweedSTAR finale where all of our research will be showcased across the partnership on the 10th of November 2021 from 12 till 2 GMT time. So more information can be found at our website www.globalseaweed.org. Thank you all very much for your time.
Thank you very much, Professor Elizabeth Cottier-Cook. I think congratulations to her and her team for seeing this programme through its 4 years. It was an incredible challenge, especially during various lockdowns involving the COVID-19 pandemic. So it's a huge team effort from everyone involved, and congratulations to them too. I think it's incredible to hear the various successes of the programme that were spelt out there. And I think one of the main lasting legacies will be the networks created by the programme. Of course, you are all part of this network by attending today, and you can find out a lot more about the programme via our website. Let's give you the address. It's globalseaweed.org. I'd like to take this opportunity to just remind you that we do have the question and answer function on this meeting. If you look at the top of your screen, you will see an icon with 2 speech bubbles with a question mark in it. If you want to look at that, that is your chance to ask a question of any of the speakers today, or ask a question about the programme in general. I would encourage you to put your questions in, and they'll be logged and asked at the end of the session. We're now going to hear from Professor Claire Gachon from SAMS, and she is also the Work Package 3 leader in the GlobalSeaweedSTAR programme. She's going to speak on exploring, harnessing and conserving marine genetic resources towards a sustainable seaweed aquaculture. So without further ado, I'll hand over to Professor Gachon.
So, hello everybody, my name is Claire Gachon and I'm extremely pleased for the opportunity to be speaking this morning about the GlobalSeaweedSTAR project. So moving on from Lisa's presentation, my talk is entitled Exploring, Harnessing and Conserving Marine Genetic Resources Towards a Sustainable Seaweed Aquaculture. Like Les, I'm based on the Scottish Association for Marine Science in the UK, and I also hold a second position in the Muséum National d'Histoire Naturelle in Paris. So this talk is effectively a summary of a paper that we published earlier this year in the journal Plants, People and Planet, and in which we tried to encapsulate the general ideas behind GlobalSeaweedSTAR. So here I really would like to stress that this paper, putting together this paper, was a collective effort among carrying the voice of the group of people who's worked extremely hard on this project. So the first point that we are making in this paper is that seaweed cultivation is changing very fast. So if you're looking at this table, and I'm sorry, it's a bit complicated, but it's directly taken from the paper, so you can refer to it afterwards. Effectively, what we are showing, and what is it's quite commonly known, is that within less than 10 years, the global production, both in weight, in fresh weight, and in billions of dollars in value, has increased tremendously, and that is basically for all the main seaweed species that this increase has been taking place. And this is a trend that is already well documented. But something else that is actually emerging, and which is much less well known yet, is that there is a tremendous, over the same period, so in less than 10 years, there's been a tremendous increase about the number of certified varieties that are deposited to this international organization called the UPOV, and that's the International Union for the Protection of New Varieties of Plants. And basically, that's something between a patent and a copyright for breeds, so for live seed. And what this trend shows in my mind is that there is an increasing awareness about the value of not just the crop, but also the value of the seed, which is being used by the farmers to crop the seaweeds, and that this is really showing in this trend. So this increase in the number of registered varieties is directly linked to the increased efforts of breeders to actually produce seed that is usable by farmers. So this development of breeding is actually, I would say, a new frontier, and this is actually quite crucial for the sustainability and for the development of the industry, but also for the value chain, because it really, whoever owns the seeds basically will have great power on this industry. And the interest of breeders at the moment is really about this, what I call this frontiers in seaweed cultivation. So the idea is that and especially for euchymatoids that are cultivated in Tanzania, sometimes sexual reproduction is difficult in culture, and that means that breeding itself is extremely difficult. And one of the very few options to actually develop new varieties is to go to the wild to actually collect interesting seaweeds from the wild and put them directly in culture. But then if you want to do that, the immediate second problem is that there is very little baseline knowledge on the wild genetic diversity that could be used for cultivation and breeding. And some of the questions, really very basic, that we encountered, not just in Tanzania, but in pretty much all the countries that we've worked on in GlobalSeaweedSTAR, is to know what species occur where. And really how diverse each species of Euchemocarpa ficus was. So how many genotypes or haplotypes could potentially be identified and potentially be brought into culture. And then the next challenge is really how to keep these seaweeds collected from the wild alive, how to propagate them, and to grow germplasm for farmers. So there is a huge need for actually performing what we call biobanking, and that all these questions that we addressed, that basically were at the heart of this work package that Liz has been presenting, that was entitled Improve. So another aspect to consider, and especially considering that people are going in the wild to get new varieties of seaweed, and that is so difficult to do, is that there has been a lot of movement of seed from, especially by the industry, from the industry that has been introducing high-performing plants, mostly from the Philippines to other countries, and that includes Tanzania, Madagascar, and other Western Indian Ocean countries. And well, Liz was mentioning that the industry, so seaweed cultivation, is facing a number of problems, and one of these problems has been the increase of diseases globally. And judging from other aquaculture activities, there is a possibility that introducing seaweeds, which is very good for industry and supports the economy and the local communities, but the possibility that actually bringing in high-performing seaweeds from other countries would also mediate the import of disease and pathogens. And then comes the question of how do we assess that risk and how do we mitigate that risk? How do we control it? How do we promote good practices? Both by the industry but also by the farmers, about the movement of seed, but also about the cultivation practices, so that we maximize the benefit for the industry whilst minimizing the negative effects such as disease outbreaks. A second question relates to the possibility that when you import high-performing, fast-growing seaweeds from other countries, then they might just escape from the farms and they might overgrow the local flora. So there's the risk as well that the native seaweeds might become invasive. And again, it is important to support the industry, but we also need to bear in mind this conservation issues. And here, I guess that this map is really illustrating very well that this industry, and especially Caprificus and Euchemocarpa cultivation, is a globalized industry. So it was very important for us to be working at country level and to have local national teams, including in Tanzania. But it is very clear that addressing these questions and getting an answer as to the picture that what is happening requires a global effort. And that is why we actually came up with the idea of GlobalSeaweedSTAR. And really the general aim behind this is to help individual countries, but also to develop a global picture that will inform global policy. So I will not tell you about the results of what we did, what we found, because that's really going to be covered tomorrow. by the young researchers who've been working on this project. But all I'm going to finish my talk with, this is pretty much my last slide, is really to show how much we need scientific evidence to inform policy making, and how much more information we need on seaweeds than is already available for their species. So, as I was showing, we need to mitigate conflicting requirements between supporting the industry and taking risks for conservation, and we need to be able to strike the balance with as much information as possible. However, when you look at how endangered species are represented in this table, what you're showing is that for vertebrates, there is some baseline data existing for about 2/3 of vertebrates. When you're looking at flowering plants, it's about 1 in 10 that has been assessed for their conservation status. For invertebrates, like insects, you're kind of falling at 1 in 30 species. When it comes to seaweed, it's 1 in 1,000 species for which there's data available. So that really shows how little knowledge there is about seaweed. And when you're thinking about the ecological role that seaweed play in coastal ecosystems, they're effectively ecosystem builders. They're like the trees in a forest. If you remove the seaweed, if you lose them, if you affect seaweed communities, then it's pretty much as if you were affecting a forest, except that it's underwater. And everybody is aware of how much human activities would change and affect a forest on land. And there is evidence that if you develop an industry and you do it the wrong way, then you might face serious ecological consequences. What I'm trying to show here is that we know that the economy depends, and human livelihood depends on marine environments, but the amount of knowledge that we have in seaweeds compared to what we have on plants and on trees for forests is far, far below. So if we want to develop this industry in a proper way, then there are really many more questions that we need to address, still need to address in the seaweed industry, as opposed to what is already known on land. So with that, I would just like to say thank you, and to also put up the final slide from this, and to say that we'll have a grand finale of the programme on the 10th of November. Thank you very much.
Thank you to Professor Gashon. We will now hear from Professor Juliet Brody. She's based at the Natural History Museum in London. And she was also the Work Package 1 leader on the GlobalSeaweedSTAR programme. She is going to speak on the value of scientific evidence and capacity building or knowledge exchange for the seaweed industry. So we'll now hear from Professor Brody.
Hello everyone. First of all, I want to thank Dr. Flower Masuya for inviting me to speak today. I'm going to talk about scientific evidence, capacity building and knowledge exchange. When I was thinking about this talk, I found myself going back to where we had started with this project, and perhaps I will be stating the obvious, but I wanted to reflect on these concepts in the light of nearly 4 years of global seaweed. So starting with scientific evidence. Scientific evidence is to support or counter a scientific theory or hypothesis. It's also the use of evidence to, for example, apply theories to practical problems, and that's very pertinent to global seaweed. It's empirical, it's based on verifiable observations, it's interpretable, and above all, it has to be rigorous, and the strength is in the statistical analysis and scientific controls. And data can take many different forms, and it can be displayed in many different ways, as you can see at the bottom of this slide. But gathering scientific evidence can take a long time, and its impact may take many years to be realised. But once there is a scientific framework that is robust, that is in place, there is much scope for application. And I want to give you an example here to try to illustrate this. And I go back to Crundus crispus, which I've worked on for many years. And I think it makes a very good model for the type of work that we've been doing with the eukumatoids. And the reason why is because we have a lot of knowledge about it. We know its life history. We know about its carrageenan in the different life history phases. We know about the blades and what happens over the period of a year. And we know about the endophytes that invade the thallus during the year. Now we also have information on the microbiome of Crundus crispus, and Georgia Ward, a postdoc with the project, has developed the methodology to study the microbiome, and it's the knowledge of the life history and the phenology that has been invaluable in interpreting the microbiome changes over the seasons. And that scientific evidence has been applied to the eukumatoids. It has enabled us to interpret the morphology and compare healthy and diseased individuals, and we have the methodology to study the microbiome. And this application has been possible in a relatively short period of time. And this is where capacity building comes in. To apply a scientific method or develop skills or acquire new knowledge, there is a need for capacity building. So how is it defined? Well, the United Nations has the following definition. So capacity building is the process of developing and strengthening the skills, instincts, abilities, processes and resources that organizations and communities need to survive, adapt and thrive in a fast-changing world. It's about transformation. It's about that transformation generated and sustained over time from within. It's beyond just practical tasks. It's more than that. It's about changing mindsets and attitudes. And we've done a lot of capacity building in this project, and everybody has contributed to that. For me, one of the most exciting capacity building experiences was when Janina, Joseph and I ran a taxonomy workshop at the University of Dar es Salaam. And Janina took the group through the process of DNA extraction and amplification. And this took a whole day to do. And at the end of the day, there was huge anticipation as to whether this process had worked. And when we got the results, it really was a magic moment. And you can see the arrow which shows the bands of amplified DNA. And so then we were in a position to be able to sequence the DNA and determine the species and the haplotypes. And a lot of that scientific information now has gone into our understanding of the taxonomy, the haplotypes of these eukumatoids in Tanzania and in our other partner countries. And we now have a much better idea, which will give us a much more powerful tool for the seaweed industry when it comes to looking for things like new strains, for example. And I'm sure you'll hear a lot more about that over the next 2 days. And this brings me on to the third concept. This is knowledge exchange. So this is a process which brings together, for example, academic staff or users of research, stakeholders, if you like, wider groups, communities, to increase the impact of research. It's really a very broad concept, I think. And what it does is it encourages the sharing of ideas, of data, of experience and expertise, and it's mutually beneficial to all the parties involved. And there are many benefits to knowledge exchange, and these might be things like creativity or engagement, building networks. And it also might be a way of opening up income streams. But it's sort of the wider engagement, and it's a very, very important part of these projects. And one of the things that we have been able to do over the last 3 years is to hold monthly Work Package 1 and Work Package 3 meetings. And that has been a great way of exchanging knowledge on a very regular basis. And through that, we've also been able to identify what we need in terms of capacity building, and it's also led us on to developing new scientific projects. So I decided to have a look more closely at the relationship between scientific evidence, knowledge exchange and capacity building. And the three really are highly integrated. So you might produce scientific evidence, you might then exchange that knowledge, that might raise some capacity building, and so on, and in all directions. And I've just put a few examples here of the sorts of things that we've been able to do in this project, for example. So let's start with eukymatoid morphology, the scientific evidence. Well, when we started, there was some capacity building. So there was some taxonomy, some histology through workshops. And then that led to developing the scientific evidence. And then that knowledge was exchanged through more workshops. And then, for example, we had visits to each other's countries. And I know for my part, I gained a great deal of knowledge from just being able to go and meet the seaweed farmers and to work with the people in Dar es Salaam. So it's very much through all these exchanges that we all build capacity and we all exchange knowledge. And there have been some really fantastic outputs from this, and some of them you will hear about today, I'm sure. So Ivy's disease manual. People have given lots of presentations to lots of different groups. There have been peer-reviewed publications. There's also production of seaweed identification guides. And I think one of the highlights for me has been the work that Sadok has been doing in the herbarium, which will make all the data available there globally available. And that's a very, very interesting and useful data set. And then the work of Work Package 1 and 3 is also feeding into the policy briefs. And just to conclude, the project has generated a great deal of scientific evidence. And when it wasn't possible to work in the labs, we were able to hold virtual workshops, and these will continue to the end of the project. And I've seen the young researchers blossom, and that gives me great optimism for the future of the seaweed industry. And I finally just want to really thank everybody, to Dr. Flower Masuya, to Dr. Amelia Burio, the ECRs, and Ivy and Sadok, and the postdocs, and Janina, and also to the seaweed farmers, and to enable us also to have an exhibition at the Natural History Museum. And you can see there these very beautiful herbarium specimens of the eukymatoids. So thank you all very much, and I hope you enjoy the rest of the conference.
Thank you very much to Professor Brody there. Next speaker is Dr. Anicia Hurtado, who is leading our research effort in the Philippines. She is based at the University of the Philippines, Visayas. So I'll now hand over to Dr. Hurtado.
Good afternoon and good morning to all, and hope everybody's well. In behalf of the GlobalSeaweedSTAR Philippine team, let me thank Flower and the rest of the Tanzanian team for the invite to be part of their SBP event. Today's presentation is all about safeguarding the future of the seaweed aquaculture industry of the Philippines, that is, GSSTAR Philippines contributions. Asia is the biggest seaweed producing in the world, topped by China, Indonesia, Republic of Korea, the Philippines, and Malaysia. China and Korea produce temperate seaweeds like Saccharina, Ontaria, and Porphyra, while Indonesia, the Philippines, and Malaysia produce mainly Capophycus and Eucheuma and a little of Gracilaria. In terms of Capophycus and Eucheuma cultivation production, Indonesia, the Philippines, Malaysia, and Tanzania produce this much in that order. Looking at the graph of the upper corner, left corner, it is reflected that there is a decreasing pattern of production in the Philippines. And along this decreased production, there are 5 major phyconomic issues. 1, repeated vegetative propagation of K. alvarezi, K. striatus, and denticulatum for that matter. Since 1970 to the present times, cuttings from the harvest, selecting only the young and healthy branches, are taken as new seedlings for the next growing period, and this is repeatedly done. 2, long-term production as a monocrop via extensive surface cultivation. Both practices led to low genetic variations and loss of strain vigor, further leading the biomass susceptibility to pathogens, diseases, and epi-endophyte infestations as shown on the picture on the right. 3, poor farming practices and management and lack of biosecurity measures. Despite available new technologies to be adopted from local research and innovations and from other countries, traditional practices handed down from the first generation of seaweed farmers to their next kin still prevail to the present times, leading to low productivity and overall production. 4, adverse effects of climate change, especially in coastal shallow areas. Therefore, a shift from shallow fixed off-bottom cultivation to deeper waters using hanging long lines, multiple rough long lines are encouraged in available cultivable areas with corresponding appropriate species and strains and culture techniques. And 5, the existence of several risks, especially at the production segment by the seaweed farmers, which must be addressed seriously to sustain the livelihood of tens of thousands seaweed farmers. So the biggest question on how to address the declining production problems, as seen at the upper left corner slide, keeps on bugging the stakeholders. There are 4 major possible strategies to address these problems. 1, conservation of wild populations as sources of new stock. Based from the GlobalSeaweedSTAR research results, we have still available new stocks to choose from. Biobanking of this potential new wild population is thus imperative for future sources of mother plants for domestications after a thorough research and ultimately for possible commercial cultivation. 2, of seedling banks through the use of tissue culture techniques and sporulation to generate new and improved seedlings. There are available technologies for both to be adopted. 3, whatever produced in the lab tissue culture and sporulation, the establishment of landscape-based nurseries is necessary to generate and scale up year-round availability and access to good quality seedlings. And 4, we must adopt good aquaculture practices, or GAQP for seaweeds, from A to C. That is from selection of cultivation site and species and strains, farm management and biosecurity measures, harvesting, post-harvesting, to marketing of the dried seaweed. In 2017, GCRF UKRI funded the GlobalSeaweedSTAR project for the Philippines together with Malaysia and Tanzania along 4 work packages, namely 1, pest and disease infestation, 2, biosecurity and farm management, 3, stock improvement, and 4, socioeconomic resilience. So, in order to fulfill all the objectives, several field surveys and interviews were conducted in the country. in particular the 4 major producing provinces like Palawan, Bohol, Zamboanga, and Tawi-Tawi from 2018 to 2019. The field surveys were completed in December 2019, just in time before COVID-19 started. For package 1, ice disease at all sites was at low prevalence rates, below 25%, with an exemption in one site where prevalence was 100%, that is in Davao City. Epiphytic filamentous algae, black spots, and evidence of grazing were recorded in several farms with low prevalence, that is 0.2 to 11.2%. Moderate prevalence, that is 26 to 50% of macroalgae epiphytes like sargassum and ulba was reported in Luzon. For package 2, in general, knowledge was fair across the region. That is 50 to 75%. Attitude was good at more than 75%, and practices was fair at less than 75%. This study identified the gaps in KAP towards pest and disease outbreaks. Likewise, it provided robust evidence for seaweed policy development. And for the highlights of package 3, diversified color variants of wild and farm Capophycus and Eucuma were identified. Capophycus alvarezii and K. striatus are distinct from Eucuma denticulatum as to external morphologies and molecular analysis. There is the presence of new haplotypes, new possible species from the wild as sources of future cultivars. For package 4, a strong reliance on internal support sources, that is family, across the selected parameters, and a gender difference on the extent of access to external sources were collected. It highlighted the relevance of using social network analysis in value chain analysis to understand the relationship patterns among the actors and their implications on policymaking and overall governance of the seaweed industry. And risk management from the different value chains were identified. To highlight our efforts and accomplishments, to this date, we have 6 publications in scientific peer-reviewed journals. Likewise, a brochure in 4 different languages written in English, Filipino, Bisaya, and Tausug for different stakeholders and academia and interested parties are now available. And for information, education, and communication materials, we have also posters, and it has been launched and being sent to UK partners for possible uploading to the website. Definitely, our previous accomplishments at CIFTEC AQD, our collaborations with research institutions and with seaweed farmers nationwide, and most importantly, the milestone we achieved at GlobalSeaweedSTAR project will propel to a higher height in strengthening and safeguarding the future of the seaweed aquaculture industry of the country. We all look forward to a brighter tomorrow of the seaweed industry of the Philippines. And we are hoping for further collaborations with partners in UK and elsewhere. Thank you very much for your attention.
Well, thanks to Dr. Hurtado for that interesting presentation. We're now moving on to our next speaker, who is Professor Viking Lim. She's based at the University of Malaya. She also heads up our research effort in Malaysia. And obviously I'd like to take this opportunity to mention that she was this year named one of the top researchers in Malaysia, and her work on GlobalSeaweedSTAR obviously contributed to that honour, so congratulations to her. I'll now hand over to Professor Viking Lim.
A very warm greeting to all of you. I am Pek Im Lim, the DP leader of Malaysia under the program of GlobalSeaweedSTAR. Today, it is my great pleasure to share with you the prospects and challenges in the growth and development of eucalyptus cultivation industry in Malaysia. This is the map showing Malaysia. As we can see, Malaysia harbors an extensive coastline, and we are also rich in seaweed resources where this provides natural ecosystem for the growth of seaweed aquaculture industry. Despite of long coastal area, the only location in Malaysia where seaweed cultivation is carried out commercially is in the state of Sabah, where the government have designated a total of 40,500 hectares for seaweed cultivation. However, this allocated area is not all being taken out for seaweed cultivation. The seaweed cultivation in Malaysia started since 1970 as a trial cultivation. Since 1980, the government took over the project, and ever since then, various incentives have been given through various programs in Malaysia. Despite various initiatives have been carried out by the government, however, we have seen the decline of seaweed production since the peak in 2012. The involvement of Malaysia in the GlobalSeaweedSTAR project is timely in helping us to address some of the issues of challenges they are facing in seaweed aquaculture industry. The work of GlobalSeaweedSTAR include disease detection, farm management and regulation, improvement of genetic resources and stock resilience, socioeconomic resilience. Through the work packages, we hope that we're able to secure a resilient food system, protection from environmental shock, and supporting sustainable livelihood through innovation. The various packages of GlobalSeaweedSTAR are actually addressing issues and challenges facing by seaweed aquaculture industry in Malaysia. WP1, which look into pests and diseases, and WP3 looking into the genetic diversity as well as climate change resistance on the cultivar, while WP2 look into aquaculture practice, and WP4 look into the value chain as well as price stability. Next, I would like to share with you some of the highlight of research finding from GlobalSeaweedSTAR project. Now I would like to report on the finding of the WP3. Based on our previous study, we have shown that the genetic diversity of eucalyptus cultivated in Malaysia is relatively very low. But after 10 years, with the funding from GlobalSeaweedSTAR, we still observe that the number of haplotypes being cultivated is really very low, with the only addition of one new haplotype for Kappa ficus striatus. But what is good news is through the intensive sampling at the eastern part of Sabah, we have discovered there's a lot more wall population with new haplotype that can be potentially used for cultivation. For WP1, we look into pests and diseases. Pure before our involvement in GlobalSeaweedSTAR program, the Eugema-associated EFA identification are solely based on microscopic examination without confirmation from molecular data, and we do not know the relationship with the host generalist or specialist. Through molecular identification, we have discovered that the EFA associated to eucalyptus in Malaysia comprise more than one species. Some of the species are Melanotamus, Ceramium, Galeella crodrea, and the work is currently ongoing, and we believe there are a few more new species to be described from this work. As regard about distribution of EFA, we found that higher diversity and density of EFA are found on the farm than the wall eucalyptus, and the most common EFA found is Melanotamus. Now let us look into WP2, where we look into the biosecurity, policy, and farm management. In this study for Malaysia, we look into the biosecurity risks involved, evaluating the existing policy implementation, as well as applying biosecurity in the farm system where a sentinel farm study being carried out. In order to identify and evaluate the biosecurity policy implementation in Malaysia, KAP survey as well as the study and evaluation on the current existing policy being carried out, and we found that in general, farmer and government officer biosecurity were moderate. Farmer biosecurity attitude was moderate, and for government officer, they were good. Farmer biosecurity practices generally poor, while for government officer was moderate. Okay, the biosecurity application on farm level cannot be implemented due to unclear in guidance, divergence of biosecurities among stakeholders. Majority farmers are individual small-scale farmers that limited awareness on farm management. In order to find suitable biosecurity measures on farm level that are applicable and cost-effective, a sentiment farm study of 40 days were carried out, in which the biosecurity application on farm include detection of disease and pest pathway on farm, prevention of disease occurrence by removing the disease pathways such as epiphyte, epiendophyte, biofilm waste covering the crop and ropes, and educate management of farm system through regular control the environment, assess farm daily, practicing good crop management measure. And based on the biosecurity measure, to minimize the disease or pest on farm can be done through regular detection on crop condition in initial and during growing process, particular signs of epiendophyte filamentous algae infestation, removing the coverage of epiphyte and the biofilm waste on seaweed crop and farm road can reduce the disease up to 75% during the peak disease season. Okay, as for the Gdpr, the data is mainly collected through survey from the collector, processor, farmer, cooperative, as well as exporter and government officer. Some of the main findings of Gdpr are: migrants are found to contribute more than half of total seaweed production in Malaysia. However, they can't legally access to permits, farming aid, healthy seed, or training. Besides that, there's lack of coordination in seed value chain, which is less development of marketing and downstream activity, and price fluctuation had caused instability income to the farmer. Now I would like to summarize the key finding and the way forward. In general, we still find that there's low genetic diversity of cultivar being cultivated in Malaysia, but the good news is we have rich diversity of new haplotype of eukaryotic that can potentially be developed as new cultivar. Higher number of EFA in farm than wild population. Could it be due to the same cloner have been used and propagate vegetatively for 50 years that make them more susceptible to disease and pests? Besides that, the information on the EFA involved can potentially be developed as molecular marker for early detection, and probably they can be incorporated in the biosecurity application. Our study has shown that biosecurity application may potentially reduce the disease infection up to 75%. There's also a need to include access of aid and training for migrant farmers to boost the seaweed production in Malaysia. There's a need to have a center collection for dry seaweed to avoid fluctuation of price, and there's a need to enhance the coordination and incentive for the downstream activity such as marketing and new product development. I would like to conclude my talk by thanking all the ECR that are involved in the Global SeaweedSTAR project in Malaysia, as well as the officer from Department of Fisheries Sabah for their kind assistance that have given to us throughout the project. Mostly, we'd like to thank you, Global SeaweedSTAR, for the funding in supporting the research work. Thank you.
Thank you to Professor Viking Lim for that presentation. There's some clearly excellent work going on in Malaysia as part of the Global SeaweedSTAR programme. At this point in today's proceedings, we're going to have a question and answer session. We already have a couple of questions have come in during today's session. However, if you do have a question you'd like to ask, please input that now. As I said before, the question and answer function is at the top of your Teams display. It's two speech bubbles with a question mark in one of them. If you select that and type in your question, we can still accept them now as we continue the discussion. So I'd like to invite my colleague Helen Brody to maybe present the first question.
Hello, Ewan. Thank you for that. The first question we received was during Professor Gashon's presentation earlier, and it asks, what about selecting superior strain from the wild and cultivate them on large scale? Will it cause any risk of invasiveness? I'm wondering who can answer that question.
Maybe just on the point of invasiveness, perhaps Professor Kotia could take that one on.
Hello, yes, I'm here. Can you hear me, Ewan?
Yep.
Are you there? Yeah, oh good. Okay, thank you. Yes, I looked at that question as it came in, and I wondered whether Claire was going to jump in, but I'm not sure whether she's able to join us today. But it got me thinking of some other species that have been cultivated, some other superior strains. I was thinking of the Chrysostria gigas or Megalana gigas, the Pacific oyster that has been moved around to many countries in the world and is cultivated and now has gone on in various parts of the world to become invasive and spread out with its cultivation areas. And there are now obviously researchers looking into ways in which they can actually grow that oyster using forms of triploidy, so it can't necessarily go on to reproduce where it's being cultivated, but there are also issues with that. So there are obviously incidences where potentially, I think it was Capophycus was introduced into Hawaii for cultivation purposes, and it has actually spread out with its cultivation sites to a few kilometers where it's become invasive on the coral reefs there. So there are obviously issues that need to be addressed when you are going to cultivate anything on large scale. And this is one of the reasons why in our 2016 policy brief, we did actually put a recommendation in that you do obviously try first and foremost to cultivate strains that you already have that are native to your country rather than introducing any new species. So that's first and foremost to take sort of that precautionary approach, but it may well be that there are other precautions that are taken, such as, and I'm sure others will be able to come in, obviously harvesting those species before they become fertile and are able to disperse. Obviously, there are certain species of seaweed where they can fragment off and drift and then resettle. But I'm sure maybe someone else has something that they would also like to say. I think Anisha would like to. Hi, Anne.
Yeah, Liz, you mentioned a while ago about fragmentation, and after Hawaii as a problem of invasive species of Capoficus, there was also a problem in India, in Cruzada Island, and there were actually a lot of studies made there, and after a very thorough investigation, they found out that this Capoficus in Cruzada Island was not capable of producing spores. It's only the fragments wherein if they are not being nibbled by the feces, then they will just grow and grow and grow. But otherwise, they did not produce at all spores for further reproduction. So at the time when this paper came out, I think it's 2008 or 2010, then they opened up that supposed to be, that's a marine park, a marine park. So they open up. That is why India now is a bit aggressive in their farming of Capoficus. So that's the story also of the invasive species of Capoficus. Those are the only two reported countries wherein there is supposed to be invasive Capoficus. So far as my readings are concerned.
Yeah, thanks, Anne. I agree with you there. I think it's a very understudied sector, though, and I would obviously urge. I would love to work more on this particular subject area. So maybe this is a topic for a new proposal in the future. Thank you.
Thank you very much to you both. Thank you. Helen, I think we can move on to the next question.
Okay. Yes. The second question we received was from Anushka Miller, and she asks, and this was during Professor Brody's presentation, and she asks, how stable is the Crundus Crispus microbiome across a population and across different regions?
A very general question that I'll maybe put to the floor. If you could raise a hand if you feel that you want to take that one on. Yes, Professor Kotiar-Cook.
Again, I am no expert with Crundus crispus, and I realise that Juliet isn't here to answer that question. So I think if it's okay with Anushka Miller, we can take that question and send that as an email to Juliet. I think she's packing to go to the Falkland Islands at the moment. So if we can take that question to her, I'm sorry, I don't think there's anyone in the team that's got that detailed knowledge on Crundus crispus. So, but we can obviously get that answer back to Anushka Miller. Hopefully Juliet will be able to respond in the next week or so. Okay, thank you.
Okay.
Thank you. Thank you. Yeah, no, we've got lots of good questions still to come up, so we'll just move on to the next one. Helen, if you want to read out the next question.
Yes, of course. The next question arose during Professor Feike Lim's presentation, and the question asked is how to encourage more seaweed farming in Malaysia despite all the challenges that are being listed.
Okay, Professor Feike Lim, I think that's one for you.
Yep, thank you for the questions. Okay, so I think when you talk about the Malaysia scenario per se, that based on our finding through GlobalSeaweedSTAR, I think that there are two main issues that actually we are facing, that the key that we need to address. One of it is on the cultivar, because in general we do not have a good seedling. So, but the thing is, the good news is we do have a lot of new haplotypes that potentially can be developed as cultivars. So further research need to be studied in terms of testing the grow rates, the carcinogen biomass, as well as pest and disease resistant for the grow, and also the need for conservation on the wild population stock, as well as also for the value change, because at the moment Malaysia our dry seaweed is fully exported for catering overseas market, So in order to encourage the seaweed cultivation, we need to have a sustainable industry. And for that, we need to have a value-added product. Yeah. I hope I answered the questions. Yeah. Thank you.
Thank you very much, Viking. Obviously, you were the person I went to first to answer that one, given the geographical location. But I'm just wondering if anyone else has any input on that one, or should we move on to the next question? Oh, yes, Dr. Hurtado.
I cannot unmute it.
No, we can hear you.
Okay. Okay. In relation to the major problems listed under Malaysia, how will you solve, Dr. Fick-Im, the problem on the migrant workers, seaweed farmers? Because I have just read a paper published by UM also, Kuala Lumpur, on the importance of the migrant workers, seaweed workers in Semporna. And I found out from the abstract, from the entire paper, that the contributions of these migrant seaweed workers are really big, yet they are not being recognized by the government. So how could you possibly connect also to the government being the leading scientist in UM also?
Okay, I think for the issue of migrant, yep, based on our study, GlobalSeaweedSTAR, we found that they have actually contributed more than 50% of the total seaweed production. So hence their contribution cannot be ignored. In fact, they play a very important role. In fact, for the policy brief paper that we are preparing, we actually hope that we have communicated that to the authority, Department of Fishery Malaysia, and they actually know that. So I think is basically that the migrant are allowed to cultivate, okay, because mainly are those without any citizenship. Actually, we have a group of migrant actually that they don't belong to any country. So, but they are allowed to use the sea area. The authority does not give them any problem, but the thing is, they do not have the access as regard about the aids. For example, the seedlings or the official training. So we hope that the government will be able to extend that to them so that it will actually indirectly will boost up the seaweed production. Yeah.
Thank you, Dr. Fick-Im. That's a big assurance already to the migrant workers there, because there are, I think, plenty, and most of them, sad to say, are Filipinos.
Yeah, but they are allowed to cultivate. Or another way is actually the local. I know that is practicing at the moment. Either the owner of the Malaysians, they actually secure the aids and the things, and then they employ the migrant to work on the seaweed farm. So there's various ways.
That's a good move.
Yeah, but I hope that it will eventually become something that officially that's allowed. Yeah.
Thank you very much. You definitely can't say that you didn't get some hard questions today, so thank you for that one. We do have quite a few more questions, so I want to move on to the next one. Helen, if you can read out the next question, please.
Yes. Well, the next question also arose during Professor Fick-Im's presentation, and that is from Marshall at Seedling. What do you think is the biggest factor for disease in eukaryotoid? Is it environment stress, microbe, endophyte, or interaction between these factors?
Okay, I shall answer the question. Okay, based on our experience and also the field observation, I think the main things that cause the disease to take place, whether ice or the epiendophytes seaweed that take place affecting the eukematoid, is actually triggered from the factor of the changes in the environmental. Because of the changes in the environmental, it causes stress to take place in the seaweed, and the seaweed will become vulnerable. So when they are vulnerable, so the disease will take place, as well as the infestation for the epiendophyte will take place. But the work on the as regards about the cause of the ice disease, the work is ongoing. So we are working together with Natural History Museum as well as Scottish Association for Marine Science to look into what are the associated microbiome that is cause the ice disease. And we hope that in the near future that we will be able to look into that when there's a changes, because in the GlobalSeaweedSTAR, where we carry out, especially for the work of sentiment farm study, we also measure the environmental factor. And then we hope that we can link the environment factor as well as also the data from microbiome, and from there we can deduce. And then for epiendophyte, we are also now try to look into the difference between the cultivated species as well as the wild, because one of the very interesting finding that we found in our study is actually the cultivated seaweed are more susceptible to epiendophyte compared to the wild population. So I'm thinking, could be due to the same clonal propagations that we have using, same mother plant for more than 50 years that make them susceptible. So the finding of GlobalSeaweedSTAR is very crucial, is very important for the next step for how we want to sustain this industry. The effort by Philippines of doing biobanking, and also for us to search for the cultivar that is whether disease, pest, or as well as climate change to introduce as a new cultivar is very important for the sustainability of this seaweed aquaculture industry. Yeah.
Thank you very much. I think just because the question was on diseases, I'd maybe like to bring in Dr. Nsuya. At this point, we obviously launched the Seaweed Disease Manual today. Dr. Nsuya, does this question apply to Tanzania, or is there a problem with disease in Tanzania that perhaps this relates to?
Yes, thank you. This factor is also that does apply very much to Tanzania, because we see that in our case, our studies have shown that the effect of climate change, when the temperatures are increased, and then if the cultivation area is the sediment is of white sand, of the sand causes too much light, and associated with the high temperatures, these accelerate the diseases, ICS disease and the epiphytes. And actually, in the book, we talk about this one. The main factor that causes diseases is actually climate change, is the increase in the surface seawater temperatures. So in Tanzania, we have seen this quite well, that there is a strong association between the diseases and the high temperatures. Like tomorrow there is a presentation that might show a link between diseases and the temperatures in Tanzania.
Thank you very much. I think just given the time and that we've got a few more questions to take, Helen, perhaps we can move on to the next question.
Yes, yeah. The next few questions arose after the end of the presentation. And the first one is, currently there is a huge highlight in saying that seaweed farming can help in capturing carbon and address climate change problem. How true is this statement, and what is the example of species that can contribute to this?
So I guess we're looking at seaweed and carbon sequestration and maybe the best species for this. Professor Cotier, can you come in on this one?
Thank you, Ewan. Oh, thank you. Yeah, I was just thinking, it has the issue or the potential of seaweed farming to assist with mitigating climate change is coming up time and time again now, and there's a lot of interest in this. I know that in America there has been a lot of work and millions of dollars that have been put into a project over there looking at the potential for growing seaweeds offshore in terms of producing biofuels. But there are also projects led by Professor Carlos Duarte through Oceans 2050 that are looking at actually providing scientific evidence for the looking at carbon capture through using various seaweeds, and he's looking at all sorts of different species in places all over the world. He has research sites in many places around the world, so he's going to be looking exactly at this issue and trying to provide evidence for it. I know there's been recent papers produced in Australia looking at carbon capture by wild kelp forests and showing that they are very much on a par with seagrass and mangroves, I believe. So there are more and more papers coming out that are suggesting that there is great potential from the use of kelp. Obviously, the kelp needs to be somehow buried, and Professor Duarte is looking at the burial of this seaweed in the deep ocean, deep sea, rather than it being harvested, because that's not looking at sort of long-term storage capture. But I'm sort of wondering whether the potential of using farming or the portion of the farm seaweed to actually be transplanted and rebuild some of those lost kelp and also seaweed beds that have been denuded because of human activity, over harvesting or other options, whether aquaculture partly can be used to be used for restoration, which could then be used to rebuild some of these wild seabeds and kelp forests, which could then contribute to carbon capture in the longer term. So it's a question that there is some evidence now published to say that to support that statement, but there still needs to be a lot more work done on this. So hopefully I've provided an answer there. Maybe some of my co-panelists can also add to this. Thank you.
Yeah, I'm happy to take one other speaker on that question. Okay. Head to the next question then, please, Helen.
Yes, the next question was from Maricella from Stockholm University, and she asks, this is an impressive project with such high relevance. How can we continue the global effort? More site comparisons, etc., and more inclusive to other researchers working with these problems? Thank you.
Sure. I mean, obviously through the GlobalSeaweedSTAR Research Fund, we've reached out to a lot of partners across the globe. But Professor Kocha can maybe expand on that question.
Sorry, I don't want to hog all the answers session, but thank you, Maricela. Thank you for that. Yes, as Ewan said, through our Global Research Fund, we've also worked with 15 other teams around the world in other continents other than obviously Malaysia, Tanzania and the Philippines. So we have, I hope, really made this program into a global effort. But how can we continue? It's always the case, isn't it? It's always the case of how do we continue? We obviously will be looking for further funding to support the network, the global network that we have already established through this programme. We're looking to seek further funding on this. There is also a new initiative that has come up called the Safe Seaweed Coalition that is has networking and capacity building and research as part of its ethos. You know, it wants to support more of this. So we will potentially be looking for support through the Safe Seaweed Coalition to continue this network, which would be such a shame not to continue it after the end of the project in December. So we definitely would be seeking to expand or to continue somehow and to expand on this. The exact route in how to do this is not totally clear at the moment, but as I say, the Safe Seaweed Coalition is a route, and they have a huge membership to which we're, as part of the GlobalSeaweedSTAR, we're all members. So that may be the route to continue this potential, this network that we've created via this programme. So thank you. Maybe someone else has a comment as well.
Yes, I would be interested to hear from the Tanzanian perspective. Obviously, there are networks within the region, within the country, within the continent, but reaching out to a global network. Dr. Msuya, maybe get your thoughts on that, please.
I don't know if I have already unmuted. Can you hear me?
We can hear you.
Not yet.
You're muted now. I don't think we can hear you. No.
Oh, now it has come.
Now we can hear you. Proceed.
Okay. It is a long delay. Yes, actually, what Professor Kotia-Cook has said is, I think, is a way forward. In Tanzania, for example, through this diseases manual, we shared our ideas with a lot of people, a lot of stakeholders who know about this, and who are involved in research institutions, in universities, and they have also international collaboration with their institutions. And actually here, because we are in this webinar, we are already forming another network of people. So we can use this network as well to exchange ideas on how to continue. And actually, I'd urge all of you, if you have not joined the Safe Seaweed Coalition, you should do that, because that is a best place to meet and discuss. So this is another network. We link with the Seaweed Coalition. We link with our research institutions and the universities and the students and the researchers everywhere, and then we can have discussions and see a way forward.
Thank you very much to Dr. Msuya there. Some very interesting points, particularly on the Safe Seaweed Coalition, as something that people should be involved with. I think, given the time, we'll move on to the next question, please, Helen.
Yes, the next one is, how sustainable do you think seaweed farming and production is, considering transport emissions of import and export?
Okay, again, I'm going to open this one to the floor and maybe ask whoever's going to answer it to be quite brief, because we have one more question to go before the end of the session.
Kindly repeat the question, Ewan.
Yes, we can. It is, how sustainable do you think seaweed farming and production is, considering transport emissions of import and export?
Okay, I can speak for the Philippines because for all we know, we have been here since 1970. And despite the many challenges, we are still here. And the government and the private sectors are in close coordination. In fact, even Southeast Indonesia and Malaysia are also doing. The industry is now with the new roadmap of the Philippines. The industry is really in close coordination now with the academia and the research centers, and that is what I really appreciate because with my involvement, we are introducing a lot of measures on really how to strengthen the sustainability of the seaweed farming in the Philippines. And I'm so glad that with my involvement also at GlobalSeaweedSTAR, hopefully the policy we have prepared will be acceptable by the government, because we really synchronized the policy towards the attainable of that roadmap of the Philippines to become really sustainable in the next many years more to go. So I still believe that seaweed farming in the Philippines and Indonesia and elsewhere, Tanzania and Malaysia, probably Malaysia will just scale up their motivations, because I know for sure that Malaysia was there before, but it was a bit derailed. So your seaweed farming will still has a bright future, Dr. Fikim. Yeah, I know for sure that we can still sustain the robust industry of seaweed farming in the tropics.
Yeah, I think probably I add on for Malaysia, because Malaysia, I think we are on the right track. That's the government are taking the suggestions and the input from the academia, and also the roadmap being studied, and also we are actually expanding and also diversifying the species that is to culture. So I think it's sustainable. I mean, after all, we have started since 1970 and it is still today, but I just need some some challenges that we are facing, that we need to incorporate science for the seaweed cultivation, I think, to boost the production.
And Dr. Masuya, from the Tanzanian perspective, would you like to add something very briefly?
Okay. Can you hear me? Am I already unmuted? Yeah. Okay. Yes. In the Tanzanian perspective, we have been there for 30+ years, cultivating seaweed since 1989, and we're still continuing. I think the problem of emission is technical, and we need technology to reduce kind of emissions from whatever transport means are there. But considering that we have been in the industry, many countries have been in the industry for many years, it means that we can sustain this and really make this a big industry.
Okay. Thank you very much. Thank you. We do have one final question, and it's directly for Dr. Hurtado, but we're sadly out of time. So I'm just wondering if the person who asked the question could perhaps, if they can, put their contact details maybe in the Q&A, and Dr. Hurtado can perhaps get back to them separately, just because obviously I'd like their question to be answered. But obviously we're out of time today. I would just like to thank all the speakers and congratulate the Tanzanian team again on the production of the disease manual. This is obviously day one of a 2-day event, so we will see you all hopefully tomorrow at the same time, when we will hear from more speakers who have been working with the Tanzanian team. So without further ado, I will wish you a good rest of your day, or a good tomorrow, or whatever time you're at home, and I'll see you tomorrow.
Thank you.